Okay, so for skill 4, so what we had to do was we had to use this graph and label the axes and find sine or cosine and make a function model using sine or cosine, and I chose sine. So we're to write a function that if graphed it would look like this image kind of, and then we're supposed to label these axes and make it look similar. So the first thing that we can use is the a value. So a is what determines the amplitude or the height of the graph. So look over here at the sine value, or at the sine graph, we can see that it's a lot shorter than the one we're trying to get, and this is just at -1, or the heights are at 1 and -1. So for now, so I multiplied it by 2 to make a little stretch, and before the height transformation, these would be at 2 and -2, and kind of stretch out the graphs. Next, we know that the b value right here is what determines the horizontal stretch, and if we look at these two graphs, we see that the sine is kind of fatter than this one, so we have to multiply it by 2. So we would have to multiply this by 2 because the x value changes are counterintuitive. So if you multiply it by a number, it'll get smaller or increase the frequency. So we know that the period of this is 2 pi because to find the period it's just 2 pi over b, and b here is just 1. So for us, if we make the b value 2, then we can make the period just pi, which I did demonstrate, which I label the axes for this -pi/8, and then the 3 pi/8, and the 7 pi/8. And then we know that the function shifted to the right a little bit because this does not intersect like this. And then so I made it I made the c value move it over pi/4 because it looks similar to what it might have changed. And then so since things in the x value are counterintuitive, we would have to subtract the value to make it go up or right. So I made it move pi/8. To make it, I made it move pi/8. To make it move pi/8, however, we'd have to make it right in pi/4 because of the 2 we put b value. The b value essentially is multiplied throughout the whole parenthesis, the whole x value, so the c would also be affected by it. Finally, we labeled these the maxes and the mins at 8 and 4 because we know that this amplitude right here is at 2, and we multiplied it again by the b value of 2 to make it 4. So the difference is 4, we know that. And then we chose the d value of 6 to bring it up. So after we multiplied it by 2, it brought it up to 2 and -2. So we brought up 6 so it could match the 8 up here and the 4 down here. And then we were told to, so this is what our function would look like at the end. See, it's more, so this can be compared to this graph. It's a lot more similar than this one. It's been stretched out in height, shrunk in frequency, and the period has shrunk, and the height has changed as well. So if we fully evaluate it, we get the asymptotes of 3 pi/8 plus pi k. Or no, this is for the next function, actually. The same function, but with secant. So for asymptotes, so the secant function, it looks different. The secant thing looks different than what the my bad, we're gonna have to skip over this. I totally forgot to do this. So what we would have is, one second. Skip this, Mr. Edge. I don't really want you to be struggling with the time because of this. This is on me, my bad. But it's really late, and I do not want to do this again. So this is what the graph looks like now. And we know that the asymptotes are where they are, which is, we know the asymptotes are at 3 pi over 8 plus hk. So that's, first one would be like somewhere over here, 3 pi over 8 plus hk plus pi k, because at every pi there's another asymptote. So we have to keep adding it at pi. It also goes negative. And then domains are all real numbers except for the asymptotes. And then the range is negative infinity, comma 4. And the 4 is included in this, and union to 8, which is also included in it, comma infinity. And these are just the points that would be unable to work. And then we would do x-intercept. So for the x-intercept, we had to subtract 6 from both sides of the equation, and then divide both sides by 2, take the inverse secant of both sides, and then add pi over 4 to both sides, and then divide both sides by 2. And then the y-intercept, we would just have to substitute 0 for x and solve using the calculator. We get these values for those. We get the x-intercept at 1.348 plus pi k and 2.579 plus pi k. And again, we have to do this 2.579 plus, we have to do this plus pi k thing because there are more than one intercept. It keeps shifting. For the maxes and mins, we get 5 pi over 8 plus pi k, comma 8, and then that's for the max. That's what these are. And then obviously there's a plus pi k because of the constant, like maxes. And the y-intercept is at 8, like there's a line there. That's where that goes to. And the minimum is at pi over 8 pi over 8 plus pi k. So that's what this point is like, basically. And then it's actually at 4, pi over 8 comma 4. And then that we have the plus pi k there because of the repeated ones. There are many of those, so they keep on going forever.